the function f of x or f is defined by f of x is equal to 4x positive 2 raised to the power of negative 2 for x greater than negative 1 over 2. We are asked to find integral 1 to infinity f of x times dx. Now part B is as follows. The point is moving along the curve y is equal to f of x such that as it passes some point, right, but they are mentioning it as a, as it passes through the point A, its y coordinate is decreasing at the rate of k units per second, and its x coordinate is increasing at the rate of k units per second. Now we need to find the point A, find the coordinate of A. It's a lovely question. Now to handle the first part is easy. I'm going to give the solution for the first part. Now f of x is equal to 4x positive 2 raised to the power of negative 2. Now we are asked to integrate 1 to infinity f of x dx. So that's going to be integral 1 to infinity 4x positive 2 raised to the power of negative 2 times the dx. Now I'm going to use the substitution. Let t be equal to, say, 4x positive 2. You don't have to touch the limits. So dt will be 4 times dx. Now make the substitution. So in place of 4x positive 2 you have t, that's raised to the power of negative 2. In place of dx you will have dt over 4. Place that. If you were to integrate this, this is t raised to the power of negative 2 positive 1, negative 2 positive 1. You have a 4 there. You simplify this, negative 2 positive 1 will give you negative 1. And t raised to the power of negative 2 positive 1 will give you negative 1. You push this down, you get 1 over 4 with a negative sign times t. But what is t? My t is 4x positive 2, right? But there is a limit here. So the limit is from 1 to infinity. I think it's 1 to infinity. Yeah, the limit is given as 1 to infinity. So place the limits. I'll show you how to apply the limits. So let me rewrite this. So this is equal to negative 1 over 4 is taken out. So you got 1 over 4x positive 2 and the limits are 1 to infinity. Now as x tending to infinity, 1 over x will tend to 0. So you apply the upper limit, negative 1 over 4, you apply the upper limit infinity. This is a very important part. You need to write this. As x tends to infinity, 1 over x will tend to 0. As the upper limit is applied, you don't have to substitute infinity there. Just you say applying limits. Applying limits, right? Just mention that. If you apply the upper limit, as x is moving towards infinity, 1 over x will tend to 0. So this entire part will become 0. Now you have only lower limit. But lower limit you can demonstrate. You can make the substitution for the lower limit. So this is equal to negative 1 over 4, negative 1 over 4 positive 2, which is negative positive. So you have 1 over 4 times 4 positive 2 is 6, which will give you 1 over 24, right? What is this? This is integral 1 to infinity f of x dx. That's the solution for this question, for the first part. Let's do the second part. Second part, a point is moving along the curve and it says that at point A, y is decreasing at the rate of k units and x is increasing at the rate of k units. So we need to represent this. So I'm going to state it like this. So at A, y decreases. So what is the rate? Y decreases at k units per second. This is exactly what is given, right? So this means dy over dt is equal to negative k. Also at A, x increases at k units per second. So this means dx over dt is equal to positive k. So two systems you will have to establish. Now we have, what do we have? We have y to be equal to, this is the function, 4x positive 2 raised to the power of negative 2. This is what we have been given. Now what I want to do is I would like to obtain the differentiating with respect to t implicitly. So this is an implicit differentiation. So this would mean, or this would give us dy over dt times equal to, I am going to differentiate this with x, 4x positive 2 raised to the power of negative 2 times dx over dt. So this is an all important step. Now this is a straightforward differentiation. So this would give me, what, differentiating this with reference to x, so is going to be negative 2 times of 4x positive 2 raised to the power of negative 2 negative 1 times differentiation of 4x, that's going to be 4, just to retain this dx over dt as it is. So this is dy over dt. 4 times 2 is 8, it's negative 8 times 4x positive 2 raised to the power of negative 2 negative 1, that's negative 3, right? So let me write it like this, negative 3 multiplied with dx over dt. Here I have dy over dt. Now what is this dy over dt? Negative k. So substitute that. Negative k is equal to negative 8 over 4x positive 2 raised to the power of negative 3. Push it down. 4x positive 2 raised to the power of 3 times dx over dt. What is that? Positive k. Now we will have to get rid of this values. K gets cancelled. So this in turn, and negative will become positive. So I have 4x positive 2 raised to the power of 3 is equal to 8. I take the cubic, or I would say cube root on both sides. That would give me 4x positive 2 is equal to 2. If I were to move this 2 on the other side, positive 2 negative 2 will get cancelled, giving me 4x is equal to 0, which means x is equal to 0. So this is the value that I've got. Now take x is equal to 0. Let me use this part of the space. Put x is equal to 0 in y is equal to 4x positive 2 raised to the power of negative 2. So that would give me y is equal to 4 times of 0 positive 2 raised to the power of negative 2. So y is equal to 0 positive 2 raised to the power of negative 2, which means y is equal to 2 raised to the power of negative 2, which means y is equal to 1 over 4. So therefore a is what? 0, 1 over 4. So this is a beautiful question and we have solved it well.